So today in this video we'll do an experiment, that is to draw the IV characteristic curve of a PN junction diode in forward and reverse bias condition. So you know that what is a forward bias and what is a reverse bias condition from the theory. Now briefly let me explain what is forward bias and what is reverse bias. First I'll explain you the concept and what to do. Then we'll go to the setup, experimental setup, and there I'll show you how to connect in the circuit, how to connect the circuit and how to take the data. So here you can see this is a symbol of a diode, and this is your P side, this is your N side. Here P side is connected to the positive of the variable battery. Your one rheostat will be there, so that you will get a different voltage output, not a constant, it's a variable one. We can vary the voltage, output voltage, and the negative side is connected to the N side of the PN junction. So this is your P side, this is your N side, right? The symbol is this one. So this is your forward bias, and forward bias condition we will get more amount of current in the order of milliampere. Basically we will get here, you can see your electron N side means there is extra electron rich side, and this is a whole rich side, so electron will start flowing, and more amount of means we will get the current in the emitter. So what we will do in the experiment, we will increase the voltage and we will get the corresponding current. We will note down in the your record. Will keep a record of this, that for the corresponding voltage what current we are getting. And here voltage generally will give in our apparatus 0 to 3 volt range will give, and this one will keep in the milliampere order. So now what is the reverse bias? Just opposite to the forward bias. Reverse bias is exactly here what we will do, the positive side is connected to the negative side and negative side is connected to the positive side of the PN junction diode. So here one voltmeter is connected parallelly and emitter is connected in series. So this is the circuit diagram, and similarly here we have changed the your voltage. Here we will take in the readings in 0 to 30 volt range, and your current will get in the microampere order, because due to the depletion region the current will not flow. Will get a very less amount of current in the order of microampere, and we are providing more voltage in reverse bias, remember. So then what we will do, from this data we will draw a graph. This is the aim of the experiment, to draw the IV characteristic curve. So we have to draw one graph from our data that we'll get from our experiment. So for different voltage we'll get different current. Like suppose the order is 0.5 to 2.5 or 3. This is my voltage range, which I'll keep in x-axis. Then in y-axis I'll keep the current, and that will be in the order of milliampere. So you see 0.5 I am getting 0.5 volt, I am getting 1 milliampere, let's say. So similarly whatever you will get in the graph, we will get different points, will correspond for the different voltage, you will get a different current, right? Let's say in the order of in the step of 0.5 volt I have taken my reading, 0.5 then 1, like that. So I'll join all these points in a freehand. I'll draw a freehand curve, right? Then similar thing from the reverse bias, you can do two separate graph, or in the same graph you can show also both forward bias and reverse bias. So this is the forward bias. In reverse bias, opposite direction I have kept the voltage in the negative direction and current in the your downward direction. So because current will the direction of current will change, so I have kept in the y direction, and I have kept in microampere order. So microampere order in our setup, I'll show you, that will be from up to 100 microampere the range. So I'll get something like 20 microampere, 30 microampere, like that I'll get. And the voltage I am giving you, as I have shown you, 0 to 30 volt the range I'll provide to the your diode. So here I have kept the voltage range as 5, 10, 15, 20, like that, in that order I have kept, right? So this is my aim. So I'll connect the circuit, I'll change the voltage, the corresponding current I'll note down, and I'll make one table, and from the table I'll draw the graph. This is my aim of the experiment, to draw this curve, draw this graph in a forward bias. Now important thing is to connect the circuit, right? Let us go to our apparatus and connect it. So this is the apparatus of PN junction diode, and here everything is inbuilt. We will not connect any extra component. So already all the components are there in this box. So now this type of box are available. So I think if you are using such kind of your already inbuilt apparatus, then you can use this one, or you can do it with separate voltmeter, ammeter. Also you can do this experiment with separate diode, and also with a resistor and voltmeter you can also get this variable voltage. So all these things you can do, but if you are having this setup, you can also easily do it. So now this is a voltmeter, and you can see, I think the range is 0 to 30 volt, and the upper one is 0 to 3 volt. Here also similarly 1 millimeter your ammeter is there, which the bottom one is 0 to 10 milliampere, and the top was 0 to 100 microampere, right? So two range are there. Now these knobs are there. So in top it is written 3 volt, in down it is written 30 volt. So when you will use the 0 to 30 volt range, we will keep our knob to the down. When we will use 3 volt, we will keep it in up side. Similarly, when in the reverse bias case, we will get the current in microampere, we will keep it in down. When forward bias, we need 10 in the order of milliampere, I'll keep it up, right? So these are the different knobs. You can see now these are the variable voltage from these two knobs I'll get. This will give me 0 to 3 volt, this will give me 0 to 30 volt. So for forward bias I'll use this one, and reverse bias I'll this one. Now two diodes are there, one is forward bias, it is already written. So here for forward bias will use this diode, and for reverse bias will use this diode, right? This is your voltmeter, this is your ammeter, and this is your on and off key. Now this is my plug, I'll put it in this one, right, to switch it on. But before that, let me connect the circuit. So as I show you in the board, my circuit diagram for forward bias is my cell. From the cell, this is your diode, ammeter, then this is your voltmeter. So this is your circuit diagram for forward bias. Now let me follow this circuit diagram. Positive terminal is connected to the positive side of the diode. So what I'll do, I'll connect positive terminal. Here see positive, two holes are there, so both are positive. I can take any of the positive terminal. So from positive terminal to, I'll connect the positive terminal of the diode, right? This is connection done. Now I'll connect the opposite terminal of the diode to the ammeter. So from this opposite terminal, I'll connect to the ammeter. Then I'll connect the ammeter opposite terminal to the negative terminal of the variable bit cell, and then I'll connect, you can see all these wires clearly. Now I'll connect this voltmeter parallelly. So I'll do that from positive of the cell to the positive terminal of your voltmeter. Then I'll connect negative terminal to negative terminal of the voltmeter. Now my connection for forward bias is done, right? So you can see that I have connected the voltmeter parallelly, negative to negative, positive to positive. Then from positive terminal of the cell I have connected to the positive terminal of the diode, then negative to the emitter, and other terminal of the your emitter to the negative terminal of the cell. Now I'll switch it on. I'll put the plug here and I'll pull on, switch on the circuit. Now you can see the circuit is on. So this is your off and on condition. Now you can see I have kept this knob in 3 volt and in 10 milliampere range because I am doing forward bias condition. So my forward bias condition, my current will be more, it will be in the order of milliampere range. So I have fixed in milliampere range, and also voltage, less voltage required, so I have kept in 3 volt range. So what I'll do, I'll just keep on increasing this voltage and I'll note down the current, corresponding current on my emitter. So as you can see clearly, I have kept, you can see clearly that when I am rotating this knob, the voltage, I am providing more voltage. Let's say now it's 0.5 volt, because you can see I am using the upper scale, not the lower scale. Lower scale is 30 volt range, so I am using the upper scale, that is 0.5 volt voltage I have provided. Now I'll note down the corresponding current. You see that current, I am getting some current, right? The current I have used 10 milliampere range, so the current is approximately 1 milliampere in between 0 and 2, so it is approximately 1 milliampere. Now what I'll do, I'll note down my I'll make my table. So my table will be like this: V and I. I'll make table. So my voltage is, I provided 0.5, the current in order of milliampere I am getting, it is 1 milliampere, right? It is 1 milliampere. So then again I'll take 4 or 5 more reading, because I need to draw the graph. So different, so again I'll increase. Let's say now I'll provide 1 volt to the circuit. So I provided 1 volt. Now you see again the current increased. So current is in between 2 to 4, not 2.5 exactly, 2 lines. It is on the third line after 2, so that you can see 0 to 2, 10 lines are there. That means the least count is 0.2. So it's on the second line, third line, so it will be 2.6. So I'll note down that for 1 volt my point is 2.6 milliampere I am getting in the current, right? So I think it's clear. The forward bias, similarly I'll keep on increasing and I'll take few more readings. Now let us go to the reverse bias condition and how will you do the connection. So I switched the circuit apparatus off. Now I'll open all the connecting wires. Then what I'll do, I'll keep everything minimum, then I'll start my connection. Now circuit diagram will be for reverse bias as I have shown on the board, that this is your negative, and so negative will be connected to positive and negative side will be connected to the P side. Negative terminal of this variable battery will be connected to P side and positive terminal will be connected to N side, just reverse. So this is your emitter, and here we will connect one voltmeter in the parallel condition. This is variable, this will give you with a variable voltage, not a fixed voltage. So this is the connection. Now let us do it, connect the wires. So what we'll do now, we'll connect from your variable battery to positive to negative of the, and reverse bias condition as I have told you, this diode will use. So we'll use again 0 to 30 volt, more voltage will give to the reverse bias condition. So this your battery will use. So now I'll connect positive to negative of the diode, then your positive of the diode, P side of the diode to emitter, then emitter to negative of the your battery. Now voltmeter I'll connect parallelly, that is positive to positive and negative to negative. So now my circuit diagram for reverse bias is done. This is reverse bias condition. So here I have connected the diode in the reverse bias condition, that is positive side is connected to the P side is connected to the negative terminal and N side is connected to the positive terminal. Clear? Now I have to change this knobs because it's in the up means it's 3 volt and up here also it's 10 milliampere. Now I'll keep it down. Down means I'm changing to 30 volt range. Now I'll use 30 volts, so I have kept it in the down. Here also I'll make it down because 100 microampere I'll use. Now you see in this ammeter 0 to 100 is the top one and here it is 0 to 30 is the down one. So I have to see only this line, not the up one, because up one range is 0 to 3 volt, so I am not using that one. Now let us see, switch on our circuit again and let us see that what type of result we are getting. Now my circuit is ready. I'll switch it on. Now it's on. So I will take some data, right? I'll take some data. So now I'll increase the voltage using this knob, not this, because this is 0 to 3 volt range. So let us see how the voltage and current are increasing in reverse bias condition. Now I'll increase this voltage. You see, first again I'm saying I'm using 0 to 30, that means down one. So it's now not 0.5 volt, it's 5 volt, not 5 volt. Let me increase a little bit. Yes, now it's 5 volt. So for 5 volt I'm getting current, not the down one, I'm taking the upper range. So now it's 0 to 20, that means each one is 2, so it just crossed half mark, that will be 12, right? So my current and voltage will be, I'll note down again like the previous one. So here will be your voltage, here will be your corresponding current for that, right? So voltage I have fixed at 5 volt and the current I am getting as in the order of microampere I am getting. So I got it's 12 microampere for 5 volt I am getting. Now let us take one more reading so that you will take 4 to 5 readings to draw the graph. Now let me draw the keep it at 10 volt. So for 10 volt I am getting you can see just after 20, that means it will be 22 microampere, one line after 20, so each line is 2. So this is your least count is 2 for 0 to 100 microampere. So this is your 10 volt and I am getting the current is 22 microampere. It's very micro is very small, so I'm getting in the order of microampere. Now similarly you will get keep on getting the different currents when you will increase the voltage. Now let us check where the breakdown is happening. So for breakdown we will keep on increasing. At breakdown what will happen, sudden increment of current will be there, so it will cross the depletion region. Now you see I have increased the voltage up to 20 volt, still the current is increasing slightly, little in the order of microampere. My voltage is now beyond 20, it's beyond, it's approaching to, now see suddenly the current increases and from here to here 24 to 25 I think, when the voltage is not down here in this order, suddenly the current is increasing. It's not increasing smoothly, sudden spike is there, right? Like this in reverse bias a sudden spike is there. This point is breakdown I am getting here at this voltage, right? So this is the experiment. Now you have the data, you can draw one graph as I have explained you. So now I'll switch it off. I think you will able to connect it. If any confusion, you can write in the comment box so that I can explain to you. Now let us switch it off. So thank you. See you in another video.